Hi, this is Mr. Max. I am doing my third part on my series based on measures and mensuration. So I'm going to go just directly to a question. So we have a diagram here and it shows a sketch of a net, all right? And then there's a square here, which is 10 by 10. And then there are four congruent triangles, all right? And then you can see the distance A to B is 10, M to P is 12, and obviously BP is equal to PC, all right? So all of these distances as you go around here are all equal. Right, so the first question is, what is the special name that is given to each of the four triangles that you see here, right? So because you have got BP equals to PC, when you have two equal sides in any triangle, all right, it means you are dealing with an isosceles triangle. Okay, one of the things that a lot of students tend to make is they misspell this word. Right, so you are supposed now to find the length of BP. So you have to be a bit careful. So if you extract that particular triangle, BMP there, okay, like what I did. But you also realize that because of that perpendicular there, that the side B to M and C to M are equal. All right, so if the whole side is 10, it means then you have got a 5 centimeter there. So we will use Pythagoras now to find our required length. So when you use Pythagoras, you take the longer side, add the sum of the squares of the two shorter sides, finding the square root of that, which that side is 13 centimeters. Okay, so it's always useful to take out a right angle triangle or some triangles, and then you fill in the information from there, and then you can actually calculate what is it that they ask you to find. Right, so then the second part here, they want you to find the perimeter of the net, so I've indicated them all in red here. So basically it's all these distances here in red. Okay, so it's 8 of them, so you just multiply by 13 or add all of them up, perimeter of the net, okay, and that's 104 centimeters. Right, now they are saying that this is made from a solid, so if you obviously join all of these vertices, they come and form they come to an apex, so it basically forms a solid, and that is obviously a pyramid. Now pyramids are called or named based on their bases. So this is a square, so therefore it becomes a square based pyramid. So suppose this was a rectangle, it would have been a rectangular base pyramid. If this was a triangle, it becomes a triangular base pyramid, and so on. But so this one here is nothing but a square based pyramid. Right, so the question here involves the edges, right? So to understand the edges, let me close that particular triangle. So it's this 13 here, all these 13 that you see that are indicated, with the edges that you have at the bottom, all right? So it's 13 times 4, all right, because there are 4 of them, plus 10 times 4. So that gives you the edges, the sum of the length of the edges of the solid, all right? So not only are the edges here, the triangles that come down, but also at the base of the square there, all right? So if one thing that perhaps worth mentioning here might have nothing to do with this particular question, however. So you want to know how many triangular faces this pyramid consists of. Since you have a square here and a square consists of 4 sides, you expect 4 triangular faces to meet here at the apex. If this was a triangle, the base, for example, there would be 3 triangular faces, and so on. Okay, if it was a pentagon, then it becomes a pentagonal based pyramid, then you have 5 particular triangles that meet up at the apex. It's just something worth mentioning. All right, so now here they are giving us the volume, and they say it's given by the formula, or third times the area of the base, all right, times the height. So we are supposed to find the volume of the solid. Now, in order for us to find the volume of the solid, we do not have the height. We know what the area of the base is. The area of the base is nothing but the 10 times 10. All right, and we also know from our previous work that PM is 12. All right, so if I have to extract that particular triangle there, Okay, so I know this is 5 because if this distance here is 10, then from the center up to there it should be half of that, which is 5. All right, and then that particular distance there is 12. That is basically that part of the triangle. The 12 comes when you take this particular triangle and you open it up for it to be a net. Okay, so we need to find the perpendicular height, as I indicated in blue here. In order to find the height, again, it's a right angle triangle. Since we're looking for the short side, we have to take the square of the longest minus the square of the shortest and take the square root of that answer. So that answer, I'm going to leave it in third form as it's there. Okay, it's an irrational answer. And I'm going to calculate here the volume by plugging 1 over 3 times the area of the base, which is a square, 10 times 10, times the height. And then you can go ahead and give this answer correct to 3 significant figures, which is 364 cubic centimeters. Right, then I have a second question here. They're saying that paper is sold in cylindrical rolls. There is a wooden cylinder of radius 2 centimeters, the one here. All right, so you have got a paper around here. But this paper has got obviously also some sort of thickness, but we're going to get to that part. All right, so they want you to find the volume of the paper in a roll. Okay, so what you need to do is you need to be able to take the radius, the volume of the whole thing, okay, with that wooden cylinder there, and then you find minus the volume of the small cylinder that is in there, and when you subtract them, that should give you the volume of paper that you have. So it's the volume of everything, okay, and then the volume of the small one you subtract, because you want to know, because remember the wooden one here, the wooden cylinder, there is no paper there, it's a wooden cylinder, right? So this thing is just rolled around it. So to find the volume of paper, you find the volume of everything minus the volume of the cylinder, and that should give you the correct answer. So I use a different R, a capital letter R, to differentiate between my 30 centimeter for the volume of the whole, the outer one, and my 2 little centimeter for the volume of the inner one. All right, so just go ahead and you plug in your values as you have them, and you should definitely realize that you get an answer of 59,100 cubic centimeters. That is the volume of paper that is in that roll. So it's the volume of paper is equal to the volume of the outer minus the volume of the inner, all right? And when you do that, then you can actually find them. Some students, they go ahead here and they factorize the pi and the h. It's totally up to you, but remember, it's always better sometimes to show your work in a step-by-step method so that you do not make a mistake. Right, then there's a B part that says that the paper is cut into sheets, which measures 21 centimeters by 29.7 centimeters, okay? Right, so that is like a rectangular sheet now, but then it also has some sort of thickness to it, okay? So this thickness is given to you in millimeters. So when they are saying, firstly, as a matter of guiding you, you need to change this to centimeters, because somehow maybe it will involve you to find the volume and stuff like that, or the number of sheets that you can find from that particular volume of paper. All right, so when you should know that, always go back to the basics. 1 centimeter is equal to 10 millimeters. So changing millimeters to centimeters, you divide by 10. That gives you 0.0125 centimeters. That's worth 1 mark. Now here they are asking the question that I was alluding for 4 marks. How many whole sheets of paper can be cut from the roll? All right, so in order for us to do that, let's find the volume of one. I like to do my thing step by step. So the volume of one sheet, and that is why you needed to change the millimeter here to centimeters, because otherwise you are going to multiply with units that are not compatible. All right, the word compatible just means not the same. So you need to make sure that 21 centimeters times 29.7 centimeters times 0.0125 centimeters. All right, that gives you the volume of one sheet. Right, so we know the volume of the paper, so simply then we need to divide. All right, so we do get some 7,580 point something here, but we want the whole number of sheets. So that means you are not rounding, okay? So it's just going to be 7,580 sheets that can be cut into, all right, this paper that can be cut into sheets. All right, so that is how this particular question is done. So it's always worthwhile for you where you can to show your steps so that you do not lose marks. Also, the methodology works in your favor. Right, I have got a third question here. So they are saying the surface area of a sphere of radius r, they're giving you the formula, all right, for pi r squared, the volume is 4 over 3 pi r cubed. So normally this is given to you, the formula, right? They're going to give you the formula of a sphere, they're going to give you the formula of a cone, whether it's the surface area, whether it's the volume, and then we're going to do the same for a pyramid. But they're not going to give you the formula to calculate the hemisphere. You need to be able to deduce that a hemisphere is half a sphere. All right, so I'm digressing. But just remember, when you're given a formula, make sure that you understand the question. So they are saying here, all right, a solid metal sphere. All right, it has a radius of 3.5 centimeters. So I brought in a diagram for you to see. Then they say 1 cubic centimeter of the metal has a mass of 5.6 gram. So they want you to calculate the surface area. So this one is straightforward. You have to then use the formula for pi r squared with the radius of 3.5. No problem asked. All right. So you then find 154 square centimeters. That answer is the correct to three significant figures. All right. So the second one is they want you to find the volume of a sphere. Again, no problem here. You just go ahead, use the formula to calculate the volume of a sphere with the radius of 3.5. All right. Just remember the radius here is cubed, and you punch that in, you get 180 cubic centimeters, correct to three significant figures. Now, the mass of the sphere, this is now very interesting. So they are telling you here that 1 cubic centimeter, all right, has a mass of 5.6 gram. So if that is the case, then 180 or the 179 point something cubic centimeters, which is the volume, multiply that by 5.6 to get the mass of the whole sphere, all right, which gives you about 1010 grams, all right. That is how you answer that question, all right. So then some people, they go ahead and they answer that in kilograms, but it doesn't matter. We wanted the answer in grams here. Right, so this brings me to another part of the question. All right, so this question here, let me bring in a diagram. So you have got here a cylinder, all right, two cylinders, and then here you have got some spheres in this one here. So there's a displacement happening in terms of the height here, all right. The moment you put in those metal spheres there, obviously this is going to increase if that was water that is in there. All right, so the height here is displaced, so you have to then obviously do something. So this question will ask us to find that height. So let me bring in the information. Then they're saying basically what you're seeing there, diagram 1 shows a cylinder, all right. The diameter is 16 centimeters, and this is very important, all right, because one of the things I always say to students is when you're getting a question then that requires you to find something about the diameter, you need to remember that when it involves you to calculate the radius, for example, okay, you will probably have to go and find the radius by dividing 16 by 2, and that radius will be 8 as well. So take note of that. It's very important that you do not make that particular mistake. All right, so then they are saying that two identical spheres like the one that we had. So let me bring that sphere back. So these two are then placed in water, okay, as you can see. So obviously the water here, the height is going to increase, that displacement will take place there. So we need to find the height now, all right, of that for 4 marks. All right, so the first thing I'm going to do, let me calculate the volume of the water, the volume that I have in diagram 1. So the volume is pi r squared times h, that is the formula to calculate the volume of the cylinder. Our height here is 8, and take note, our radius is 16 divided by 2, which is 8. All right, so please do not make that mistake when it comes to that. All right, then we'll multiply that by 8, which is the height that we have here, and times pi. So you get 1,608 point so on and so on and so on cubic centimeter. That's the volume that you have now. So the moment you insert now, all right, so the volume of diagram 2 now, you have to increase that. Remember from our previous answer, we know that the volume of one of these metal spheres was about 180 cubic centimeters. So two of them is 360. So I'm going to add them. So now the volume here is now 1968 point blah 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 blah. All right, so now I have the volume of diagram 2. So I'm going to use the formula to calculate the volume of a cylinder, which is V equals to pi r squared times H. So I have the volume, which is the 1968. Pi, I know what radius is, and I need to find H. So essentially it means you must make H the subject of the formula, and then you just input everything else that you have. All right, so let me then do that here. So I have managed to enter it, pi r squared times H. We need to find H, and very easy. 16 divided by 2 gives you 8. 8 squared, 64 pi. So to get H alone, you divide this 1968 by 64 pi, all right, and then you write down what you get from your calculator, and then you can give the correct answer. In this case, the height would be about 9.79 centimeters. All right, so it increased. Sometimes the question asks you by how much did the height increase. Then you would be taking this 9.79 and subtract it from 8. But that's not what this particular question was asking of us. Right, then they're saying now a sphere of a different metal has a mass of 1 kilogram. 1 cubic centimeter of this metal has a mass of 4.8 grams. So when you read that question like that, it could be that you're like, oh man, what is going on here? All right, but then I always like to bring in by ratio method that I compare the information that I'm given. So they're saying that 1 cubic centimeter is equivalent to 4.8 grams. So 1,000 kilogram is actually equal to 1 kilogram rather is 1,000 grams. So I put it under grams. So I need to find the volume of this particular sphere. All right. So if I find the volume here, well, you can do your cross multiplication. You realize that, okay, wait a minute, I have to divide 1,000 by 4.8. So that gives you the volume of the sphere. So now that you have the volume of the sphere, then you can find the area, the radius, by simply again playing around with the formula. So what is the formula to calculate the volume of a sphere? It's 4 over 3 pi r cubed. All right, so we know what the volume is. All right, we are supposed to find the radius. So 4 over 3 times pi have to somehow disappear from here. Now, take note, I wrote them here in blue and red. I just want to show you what is it that I'm doing when I get rid of this fraction. So I'm multiplying it by its inverse. All right, and when you multiply anything by its inverse, it's going to leave you with that 1 here. All right, so whatever answer I get there then, which is 156.25, all right, so then I just take that answer and I divide by pi. So remember, the idea is to make r the subject of the formula. So this is r cubed, and the reverse of something cubed is the cube root. All right, so I will find the cube root of 49.7 and so on and so on and so on. So this is going to give me directly the radius that is required. And then you go ahead and then you round that particular answer as I did here, which is 3.68 centimeters, correct to 3 significant figures.